Hi, okay, welcome to session 2. So what we're going to do in this session is we're going to build on those indices and just see the questions getting that little bit more tricky. We are learning 2 additional rules. So to start off, we have our recap. We do this at the beginning of every session. So all new learning starts to build into our recap. So we're constantly forcing that memory to work. Okay, so hit pause, have a go at those and press play when you're ready. Okay, there's your answers. So pause, mark, and then we will move on. Okay, so we are going to add 2 additional rules to the rules we already have. The first one is going to be the power 0. Okay, now the power 0 always equals 1. That is our fact. So that is another fact that we have to add on to the list to learn. So whenever I see anything to the power 0, it's going to equal 1. Now, I'm not going to just leave it there. I want to explain why it equals 1. So if I have x to the power of 3, and I divide that by x to the power of 3, if I use my power rules here, it's a divide, and you're told to take the powers for a divide question, and 3 take 3 is 0. So there's just an example of how power 0 could appear, how it could happen. Okay, now we're going to change the x to a value so that we can see what's going on. So I'm going to change it to 5. So if x is now 5, I've got 5 cubed over 5 cubed. If I expand that to see what's actually going on, I've got 5 times 5 times 5 over 5 times 5 times 5. You can see that my numerator is identical to my denominator. The top and bottom match. 125 divided by 125 is 1. I could have put a 3 in there. 3 times 3 times 3 is 27. 27 is going to match with the bottom. So it's going to create this equals 1 every single time. So that's what's going on to create the power 0. So we're going to see a little bit of that in our maths during today's session. The other one is negative powers. So if I gave you 5 to the negative power 2, the most common error that I see is people wanting to link their answer to a negative. So this is the most common. 5 squared is 25, and I'm going to stick a minus in front. That is completely wrong. All right. I'm going to try and show you so there's some understanding behind what's happening so that moving forward, you will have it to help you. All right. So it's not minus 25. So what is it? I'm actually going to use a different number because 2 demonstrates this beautifully. So if I've got 2 cubed, I know that that means 2 times 2 times 2, which is 8. Okay, so we're just building some knowledge against things that we already know. Okay, now I'm going to reduce that power just by 1, which is going to give me this, which is going to give me this. And I can see that this has halved, basically, hasn't it? 2 to the power of 1 is just 2, which is 2, and that halving is continuing. 2 to the power of 0, I've just learned that that is going to equal 1. It's a fact that I now know, but I can also see it happening in this pattern when I divide by 2. Now, if I continue to divide by 2, I'm going to end up with a half here, or 0.5. But you'll see why I want to keep it as a fraction in the moment. Yeah, if I divide by 2, that will give me a half. If I divide by 2 again, it'll give me a quarter. And I can obviously keep going. Over here, the powers are obviously going to keep going. So I've gone from 2, 0 to 2 to the negative 1. I can see that is giving me a half, not a negative number. If I go to 2 to the minus 2, I can see that has given me a fraction, not a negative number. So what I really now need to know is, how do I go from this to this? What is happening? How can I do that? So we're going to concentrate on the 2 to the minus 2 just for a moment, because the quarter is a different number. And if there's 2's all over the place, we might get confused. All right. If I just ignore this bit just for a second and say it's 2 squared, that's going to give me 4. So I can kind of see where that 4 is coming from, but why is it turning into a denominator? The negative that we have in the question is actually telling me to perform something called a reciprocal. Now, a reciprocal is where we can often see numbers flipping in themselves, and we're going to see it in this as well. There isn't a number to flip so much, but if I think of 4 as a whole number and I want to make it look like a fraction, I can put it over 1. Now I've got something I can flip, okay? The 4 is going to flip to 1 over 4, okay? And that's what a reciprocal is doing, okay? If it's a whole number, you're going to see it look like that. If it was a fraction, let's say you had 2/3 and you had to perform the reciprocal on that, we're literally just flipping, okay? So that's our reciprocal. What am I doing when I see a question? I do it in a particular order. You have to do what kind of works for you. So if we now go back to this original question here, what my eye is drawn to is the negative to start off with. That says to me, oh, this is a reciprocal. So I know straight away it's going to be this. Then I put everything else underneath it. And then I do any maths I can do. So 5 to the negative 2 equals a 25th, 1 over 25. Okay. And obviously this is true even if I don't have a number. If I had a to the minus 4, for example, I know that that is going to equal 1 over a to the 4. I just stop there because I don't have any more maths that I can physically do. So that is our power 0 rule added and our negative rule added. Those are all the rules that we need up to grade 5, up to foundation. Okay, so let's do some practice. What we're going to do with this is we're going to combine, like I say, the previous rules in with some harder questions. We'll see our power 0 and our reciprocals coming up as well. So it's going to be a good old mix, hopefully, of lots of things. So the first one is 5x to the 7 times 3x to the 4 all over x to the 6. And what I want you to do here is have a go right from the off, okay? I want you to think about what you're looking at and what you could do, what you could try to get to an end result. It doesn't matter if it goes wrong. It's the first time you've seen it, but go for it. You've got nothing to lose. Okay, so what I'm actually going to do is tidy this top up, all right? I don't want that time sign there. I want one thing to represent what's on top. So 5 times 3 is 15. I'm going to add the powers because it is multiply. So that's going to give me 11. Now that is all over x to the 6. And now it's starting to look very familiar, something that I'm used to doing. I don't have anything to divide through with that 15. So 15 will be in my answer. We take away the powers for a divide. So we end up with x to the 5. And if you got that right first time, really, really well done. Because obviously seeing things for the first time is always a bit scary. This whole session may feel a bit scary. No, you'll be fine. All right, so I've got x to the power of 7 times x to the power of 2. And I'm going to raise that to the power 3. Okay, off you go. Have a go. And then press play when you're ready. Okay, so again, I'm doing this in 2 steps. I'm going to do this bit first. And x to the 7 times x to the 2 is going to give me x to the 9. That is what will be raised to the power 3. A power to a power is times, so it's x to the 27. Okay, all right, let's do another one. We're going to do 4x to the 3 times 8x to the minus 8, and we'll put that all over 6x to the minus 4. All right, hit pause, press play when you're ready. Okay, so I'm going to sort out that top first of all. That's going to give me, let's get the pen right, 32x to the minus 5 all over 6x to the minus 4. Now, 6's don't go into 32 exactly. So this is going to give us a fraction result. I can cancel it a little bit. It's just halving them, and that's as far as I can go. And then x to the minus 5 minus 4. Okay, so it's x to the minus 5 minus minus 4, which would create a plus. That's going to give me x to the minus 1. Okay, now what's important here is that you don't start seeing the negatives and be thinking reciprocal, reciprocal, reciprocal. I didn't use that rule at all, and I'm not going to use that rule. Generally, that comes in when it's numbers. When it's algebra, we just stick with the basic rules that we already have, all right? Okay, let's do another one. Let's do that. Okay, so I'm looking at the negative, do that straight away, and then I've got my 4 squared, and then just finish it off. All right, and we'll do another one. We're going to do 5x to the 0. Hit pause, press play when you're ready. Okay, we have to be really careful with this. It's not massively common, but it's creeping into these exams, and actually it's something that we really need to be secure on. We learn anything raised to the 0 is 1. So you are tempted to just write 1, but you can't ignore the fact that there's a 5 in front of it. That 5 is squashed to the x 0. So that means 5 times x to the 0. Yes, anything to the 0 is 1, but that's what we end up with. So really, really important that we do kind of home in on the section of the question that they're referring to, okay? All right, let's do one more. Let's do 2x times x to the 3, all to the 3 over x to the 12. All right, hit pause and press play when you are ready. Okay, so there are a number of steps. It's not like just one quick go. So first thing is to sort the bracket, okay? So this is going to give us 2x to the 4. Remember, you've got that invisible 1 going on there. That is still in its bracket being raised to the 3. And obviously that's over x to the 12. Now I'm going to work on that numerator because there's still more to do. So remember, and it's easy to forget this, that power 3 has to act on the number as well. So 2 times 2 times 2 is 8. And then timesing the powers, we've got 12. And that's all over x to the 12. Okay. There isn't another number acting on that 8. So we've got the 8. 12 take 12 is 0. And we're pretty much back to what we just saw, aren't we? That's going to be 8 times 1, which is 8 for a final answer. Okay, so you've had a few to play around with. I've got some for you to practice now. There we go. And I'm going to disappear. I will scroll through the answers as well. There we go. Right, let's sort that out. You can see them clearly. Okay, so well done this session. I will see you next session when we are doing all things vectors.